I am explaining a program to find the multiplication of the two numbers by taking input dynamically in runtime. Let's start the program. Data segment is used to fetch the data. Here we have taken three variables, num1, num2 and result. Num1 is used to store the multiplicand value, num2 is used to store the multiplier value, and the result is used to store the resultant value. We have taken three messages: enter first number, second number, and result of the multiplication. With the end statement, we are going to end the data segment, and with the code segment statement, we are going to enter into the code segment. Move x comma data, move ds comma ax are two statements which are used to initialize the data segment. lea dx message 1, move ah comma 9 in 21. These three statements together are used to display message 1, which is enter the first number on our screen. Move ah comma 1 in 21. H means we have to enter a value from the keyboard, and move num1 comma al means the entered value is to be stored in the num1 variable. Similarly, as we did in the first variable, lea dx message 2, move ah comma 9 in 21. H means the second message is printed on the screen, which is enter the second number. Move ah comma 1 in 21. H means we have to enter an input from keyboard, and the input is going to be stored in num2. The num1 means multiplied num1 variable with the num2 variable, and the resultant value is stored in the result variable, and later AIM operation is done. It is used to instruction corrections the value of a multiplication of two valid unpacked decimal numbers, and we are going to add to the auxiliary high and auxiliary low registers with 30, and we are moving the auxiliary register to the base register. lea dx comma message 3, move ah comma 9 in 21. H means we are going to print message 3, which is the result of the multiplication on our screen. Move ah comma 2, move dl comma bh in 21. H means we are going to represent the second value of our resultant answer. Similarly, these three statements are going to represent the first value of our resultant answer. For example, let the answer be 10. The first value is going to be represented by these three statements, and the second value is represented by these three statements. Move 4h ch and in 20h means the program is halted, and means the program is ended. Coming to the output, enter first number. We are taking the first number as 5 and the second number as 2, and the resultant multiplication value is 10. In second question, I am explaining about the architecture of the 8253. In this, we are containing three counters, namely counter 0, counter 1 and counter 2. In this, we contain three signals: clock signal, gate signal and out signal, and we contain consoles, data bus buffer, and read write logic and control word register. The data bus buffer is used to bidirectional 8-bit buffer used to interface the 8253 to the system data bus, and the read write logic contains 5 signals: read signal, write signal, chip enable signal, A1 and A0 signals, and the control word register is used to control the counters, and the counter signals are out, gate, clock. Gate is used to start and stop the counting operations, and out is used for each counter indication and compilation required to counting or timing operation. Clock is used to synchronize the circuit operation. And we are going to know signals and operations of IC 8253. Here 0 means enable, 1 means disable, here write operation and circuit shift operations are enabled, and read operation is disabled. So we are going to load counter value in counter 0, and similarly chip enable is enabled, and write is enabled, and A0 is enabled. By enabling A0, we are going to load count value in the counter 1. By enabling the A1, we are going to load count value into the counter 2. By enabling both the A1 and A0, write control word in control register. by disabling the both A1 and A0 and enabling the CS chip and RD chip and disabling the write signal, we are going to read counter value from the counter 0. By enabling the A0 value, we are going to read counter value from counter 1. By enabling the A1, read counter value from the counter 2. By enabling both the A1 and A0 signals and disabling the write signal, no operation is going to be happen, and by disabling the write and stopping the both A1 and A0 signals, no operation is done, and by don't care conditions of read A0 and A1 may disables the chip. The A253 timer is used to produce the execution programming of a program. It is also known as a counter or a timer. It generates different types of delay signals or count signals. It contains a 16-bit register